Welcome to our session in production theory. So, as we start our lesson in production theory, let us start by defining what production is. So, production simply shows the maximum amount of Q quantity that can be expressed using the quantities such as labor for K and labor for L and capital for K. So, K stands for machinery, capital, like machinery, and L stands for the labor units. In this case, labor units will look at human skills, the time, and the human effort. So literally, production function can simply be written as Q is equal to F function of capital and labor. It describes the maximum output a firm can produce, typically using the inputs capital and labor. So we use what is called the Cobb-Douglas function, which is given by Q is equal to A, K alpha, L beta. The A is simply the total factor productivity. It measures the efficiency or the technology, whereas alpha is given by this symbol, alpha, and that is beta. So our alpha simply is the output elasticity of capital. It simply measures the percentage of output from a 1% increase in capital. And beta is the output elasticity of labor, which measures the percentage change in 1% increase of labor. So in simple terms, it tells us how much output we get when we change our input in terms of labor and capital. So now let's go to our marginal product, MP. Marginal product, MP. What are these marginal products? So marginal product basically shows how much an extra output is produced when one more input is used while skipping other constants. So we have two typical types of marginal products. We have marginal product of capital, which is MPK, and marginal product of labor, which is MPL. So marginal product of capital measures the change in output when capital increases by 1 unit or skipping the labor constant. So this is called our marginal product of capital, and this is called our marginal product of labor. So the marginal product of labor measures the change in output when the labor increases by 1 unit or skipping capital constant. So I'll briefly take you back in our differentiation to understand this. We know from our product rule that if you have y is equal to 5x4, this will be dy over dx, dy over dx. So meaning we're going to multiply the numbers. So what we have there, we're going to have 20x3. So this is called the derivative of y with respect to x. We multiply 5 times 4, which is 20. 4 minus 1, which is what? 3. If we're given our q is equal to 10L3, when differentiate this, is called the marginal product of labor. It's given by the derivative of q with respect to L. We differentiate what is on the right side over what is on the left side. Anything marginal is incremental. So this will be 30L2. So this is what we call the marginal product of labor, MPL. So in a similitude, you will be given our Q in terms of capital. So if you have Q is equal to 10K4, how do you differentiate this in terms of capital? 10K4. So to start with, this is called the marginal product of what? capital. How do you find the marginal product of capital? Is the Q over the K. This is called our MPK. And what becomes our derivative there? 10 times 4 is 40. Then we subtract 1 from the K. So we're going to have 40K3. So in the event that they are combined, we have 10L3 K4. We have to differentiate them implicitly. By implicit, we mean in parts. So we can start with the Q, the L. So also differentiating the Q, the L, we leave the other letter constant as it is. So this will be called our MPL, marginal product of labor. What happens to the K? Leave the K guy as it is. So don't touch the K. Leave the K guy as it is. So K4 remain as it is. Then we're going to differentiate 10L3. What is the derivative of 10L3? It will be 30L2. So this will be our final answer. All right, the 10 is for both of them. All right. So suppose we're differentiating with respect to K, the Q over the K. This is called our marginal product of what? Capital, which is our MPK. So in this derivative, what are we going to leave? We're going to leave our L as it is. Don't disturb the L. We're interested in the K. So what do we have here originally? We have L3. So we write the L3. Then what are we going to remain with? 10K4. So what is the derivative of 10K4? 4 times 10 is 40. Then we subtract 1 from the 4. We're going to have K what? K4. So this is what we call our implicit differentiation. Implicit differentiation. Any questions
Mr.
before I
Collins,
proceed? Yes.
why is it not 40K4 and then L3?
It's the same, but it's the same. We just follow alphabetical order. The letter comes first. Okay, A, B. Who will write A, B, then B, A. Oh, yeah, it's still fine. 2 times 3 is 3 times 4. Okay. In fact, K comes before L. So it's the same thing. Are we together?
Thank you.
So now we have learned how to differentiate. So let's just differentiate based on what we have learned so far before we go any further. If we're given derivatives from halves, we're given derivatives from um, these halves. So what do we get? So we'll go to the exam question here. Just want you to differentiate for me. Give me the marginal product of labor and the marginal product of capital for part A and part B without much ado. So what is our MPL and our MPK? How do we find our MPL? Start with the first letter. What is our MPK? The Q over what? The K.
Over to K,
So what is our dummy in this case? What do we leave constant?
it's L.
It's L.4, right?
Yes.
So let's leave L 0.4. What are we differentiating? 100K.6. 100K.6. So what is the derivative of 100K.6?
So it will be 60
Uh-huh.
K
Uh-huh.
0.5.
Negative 0.4. Right? So 1 minus 0.6 is negative 0.4. Okay.
Oh, okay.
Which, if you want, you can rewrite it in positive index as L 0.4. The negative goes down. What is our negative in there? K.4. It becomes a positive when it is in here. Okay. Let's differentiate now with respect to MPL. So this is the Q over the what?
The L,
Root the L. So what is our dummy in this case?
it's 100K.
No, 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 no. Leave off the numbers. Our dummy is
Oh,
what?
okay.
K
It's K.
point what? 0.6. The number is for both of them. So what are we differentiating? 100
It's
L.
L now.
No, it's 100 L.4. So when you cut and paste this,
Okay.
we're going to remain with what? 100 L.4, right?
Yes.
So what's the derivative of 100 L.4?
So that one will now be 40
Mm-hmm.
L
Mm-hmm.
negative 0.6.
Excellent. Then how do we put it in positive index? Which guy goes down? The L, right? So we're going to have 40K.6 over what? L.6. All together. So these are the partial derivatives that we have. So now, if we're asked to find the marginal product of capital and marginal product of labor, when we've been given our L as 100 and our K as 25, just substitute. So what is our MPK? What is our MPK? Rewrite it. It is 60 L point what? 4 over what? K.4. And what is our L? 100. So 100 to the power 0.4. And what is our K? 25. When you put 25 to the power 0. What? 0.4. All together. Can you quickly calculate that on your calculator? Can you find that on your calculator?
The 60 multiplied by 100 to the power 0.4 gives us 24,000.
Everything
Sorry,
60.
sorry, sorry, sorry,
Start with
sorry.
100 to the power.
sorry. Oh, I start with 100.
100 to the power 0.4.
It's 40.
40. So 40. Actually, 100 to the power 0.4. This is the power. Looks like this on the calculator.
We are using our smartphones.
Yes.
It's 14.
Yeah, sure.
Yes.
Let me confirm that 100 to the power zero point 4. It's what? 6.309. I'm also using my smartphone.
Oh,
It can't be that 100 to the power. Redo it. 6.309. What are you getting? Confirm that. Then what is 25 to the power zero point 0.4? So this one, the other symbol that we must be looking for is y to the power x. That is what it means, the power on the smartphone. Y to the power x. So what is 25 to the power zero point 0.4? I need you to confirm that. What is so we're going to have 378.57 divided by 3.623. So we're going to have 104.49. This is the value of our marginal product of what? Capital. Okay, are we together?
yeah.
So how do we find the marginal product of labor, therefore? We substitute marginal product of labor. How do we find it? We substitute. So those are the key um, parameters. So let's go to our pamphlet just in the interest of time. You have understood how to substitute those important things. So what do we do in essence? We substituted to find the marginal productivities. So marginal product of capital, we leave the L4 as it is and multiply 0.6 times 100, which is this part here. Then subtract, we have a negative. That's what we get here. So here the negative will go down to be in the product. Okay, so they will substitute since we're given our K as 25 and our L as 100. So where there is K, we'll put what? 25. Where there is L, we'll put 100. So our final answer here is equal to 104.47 as we calculated it. Is that clear? Then we go to the other one, marginal product of um, labor. We differentiate as we did to find our marginal productivity result. So we're going to multiply and identify the dummies. So in this case, our dummy, if we're dealing with marginal product of labor, our dummy will be K.04. So we leave K.04 as it is. So when we multiply that one, we're going to get our final answer as 40K.6 and L will be the negative. Then we substitute given these figures here. Our answers will now therefore be 17.41. So what are the results? Our marginal product of capital is 104, and our marginal product of labor is 17.41. Can you manage to substitute those ones on your own? Is that clear?
Yes, we'll try to practice.
All right. Okay. Then the next part of the question was asking us to say, as a manager, discuss the implications that arise for your firm's long-term planning given your response in part one. And in your discussion, focus on the type of inputs you are most likely to invest in over a long time and some of the challenges that may arise. Okay, so now we have the two um, results of the elasticities of the marginal productivities. So now, what would your recommendations be? So, seeing that we have a higher result for the capital than for labor, as a manager, what would you recommend and what would you go for? So, with the results being shown as follows, since there's higher productivity for capital compared to labor, it indicates that what capital is more productive. So, you should prioritize the following: invest in capital over labor in the long run. Then also you should must have an optimal mix of input. So you should adjust input to a ratio where you're going to have higher um, machinery than labor units until you reach a point maximum where MPK over MPL should be equal to R over W. So currently our MPK over MPL, if we divide these ones here, we're going to get 6. So if the cost of capital rent is relatively lower compared to wages, so capital will be more attractive. So you need to compare these. So when you divide this by over that, we're going to get what 6. And also compare to say if the cost of rent, so the reward for capital is rent. So if the cost of rent compared to wages is relatively lower, then you are bound to um, invest more in machinery, in capital than in human beings, because the output you're going to get ultimately is exponential in terms of um, capital. Okay. Any questions at this point? Is this clear? Then the second part that was of the question was asking us to do what?